I think we are done enough. Hello everyone, today we would be discussing CodeChef Starters 124. I was all able to solve all problems except random coloring one, so I will discuss all the problems. Before we get started, can anyone confirm if audio and everything is fine? Okay, thanks Tony Starks. Thanks Rasid. And let's get started. Give me a minute. Okay, like I will start from the problems which were not rated for division 2. Like I'm not really like let me just check what was the solve order in the division 4. Okay, first problem was summertime. Okay, this is Mahalis likes to drink mango lassi when it's hot and only when it's hot, if and only if the temperature of a given day is strictly greater than 35 degrees. Mamles will drink mango lassi. Mamles says that today's temperature is X degrees Celsius. Will he drink mango lassi today? Print yes, he will, and no otherwise. So if we look at this problem, what this says is like that summary for this problem is like if the temperature today is greater than X degrees Celsius, then we should print 35 degrees Celsius, then we should print yes, otherwise we should print no. And if you look at the sample for 35, the answer is no. Today's temperature is 35. This is not strictly greater than 35 degrees Celsius, so Mamles will not drink mango lassi. And if today's temperature is 38, the answer is yes. Today's temperature is 38, which is greater than 35 degrees Celsius, so Mamles will drink mango lassi today. And the code for this problem is like you can either have one cout statement where the temperature is greater than 35, print yes or no. In Python, you can also do it using an if else. If x is greater than 35, print yes, otherwise print no. And like that was the solution for this problem. The second problem was cricket tournament. Udyan is organizing a 24 is organizing a cricket tournament in which n teams are participating. This tournament is a knockout tournament, meaning that the loser of each match will be knocked out of the tournament and won't play any more matches. The winner of the tournament is whichever team remains in the end without being knocked out. The tournament proceeds as follows. If there is only one team remaining, that team will be declared the winner and the tournament finishes. Otherwise, some two teams play against each other, the loser being knocked out. You think that the tournament will be interesting if at least M matches will be played before the winner is decided. Given N and M, is it possible for the tournament to be interesting? So probably let's first see like what's happening here. Give me a minute, let me just refresh. Looks like Okay, looks fine enough. So what we have been given is like a cricket tournament is going on. There are n teams, and format is knockout tournament, which essentially says at each point of time, let's say you have team one, two, three, four, five. At each point, any two teams play, and the winner continues playing, and the loser moves out of the match. For example, third versus five is the match, and let's say three wins. Now fourth is out of the tournament. This is the first match, and the remaining teams are. Now let's say let's assume that the second match is between team 1 and 3, and team 3 wins. So one goes out of the tournament now. So the remaining teams after these two matches would be. Now let's say there is a match between third match is between 4 and 2. And let's say 2 wins. So 4 moves out of the tournament. And remaining teams here would be now 2 and 3. And now the fourth final match would be between 2 versus 3. And let's say 2 wins. So 3 goes out of the tournament and the remaining teams are 1. Remaining team is only 2. So what we can see is like in each after each match, one team is out. So like initially if there are n teams, then after first match, n minus 1 teams remain in the tournament. After second match, n minus 2 teams remain in the tournament. So like after ith match, now I teams would be out of the tournament because there are I different games and I different teams have lost it. Because once a team loses, that team can no longer play again. N minus I teams remaining. And if we keep following this process, you can notice that after n minus 1th match, only one team remains. And in that case, like whatever team that remains over here is the winner team. So what we can see is like if there are n teams, then total number of matches is fixed and it is equal to n minus 1. Like any questions on this part, because after that the problem remains similar to the other problem. And now we have been given n and m. After n teams play and a winner is finalized, if the total number of matches is greater than equal to m, we should say that the tournament is interesting. Otherwise, we should say that tournament is not interesting. So what we can check is like because we know that the total number of matches are n minus 1. So if n minus 1 is greater than is less than equal to m, then the tournament is interesting. Otherwise, the tournament is not interesting. And like this is what the problem was asking us. And if I jump to my code for this problem, if m is less than equal to n minus 1, then the tournament is interesting, otherwise no. Okay, I will move to our problems like swap and unite as well, like once I'm done with this easier problems. Any questions on this one before I move to the next problem, binary parity? Okay, the binary parity of an integer n is defined as below. Write the binary, write n in binary. For example, n equal to 13 is written as 1101 in binary, and n equal to 5 is written as 101. Count Sn the sum of binary digits of n. For example, from the earlier example, S13 is 1 plus 1 plus 0 plus 1, which is 3, and S5 is 1 plus 0 plus 1, which is 2. The binary parity of n is then the parity of Sn. And S13 is equal to 3 is odd, so 13 is said to have odd binary parity, while S5 equal to 2 is even, so 5 is even parity. This should be S5, not S6. Given an integer n and find its binary parity. The parity of an integer is quite simply whether it's even or odd. We said an integer has even parity if it's multiple of 2 and odd parity otherwise. So if we look at this problem, like there are multiple steps for this problem. First, it says you have given an integer n, find its binary representation. And once you have found the binary representation, you should count the sum of digits in binary. And then if sum of digits is odd, print odd, otherwise print even. So let's tackle this one by one. First part is how do you find the binary representation of n? Like there are many ways to do it. Like in Python, you can use bin end method. It will give you 0 1 strings. And like for example, the other way is like you can also find reminder modulo to reminder when divided by 2 and then keep dividing by 2. Like for example, now if n is equal to 0, return empty string. Otherwise, we can define it recursively. If n divided by 2 is equal to 1, then we know that we can see like the large number in this binary representation would be 1. So we should return else the last character in the binary representation would be 0. Like this is one way to do it. And once we have found the binary representation, we can iterate on the given string and see like what is the sum of digit. Like the other way to do it would be like you can notice that this is n by 2. So we can also do it iteratively. While n is greater than 0 and percentage 2 and slash equal to 2. At last, this loop will return us the sum of binary representation. And once we know the sum, we can check whether it's even or odd, and that works for us. And like that was essentially the solution for this problem. Like first, you have to know like how do we find a representation in any general base B, and for like you like one thing you need is like how to n in base B. And if you know like this algorithm, then the other thing was simulating the given problem. And like as other people have pointed out, like there is also a built-in pop count function as well in C++ that also gives us like the sum of all the numbers in binary representation of n. So you can also use that method as well. Like this would be the code for this problem. Start with n, like start with sum equal to 0 while n is greater than 0. Sum plus equal to n percentage 2 and n divide by 2. Like you have taken the like you have found the last bit and you added it to the sum and then you have removed that bit from the sum. And at last, if sum is 1, print out, otherwise print even. Like any questions on this one before I move to the next problem? Okay, I will move to the next problem then. It says table strength. You have n table legs of different strength. Pillar I can bear a weight of Wi and will break if it has to bear a larger weight. You like to construct a table using some empty subset of these table legs. When you place a weight on the table, its load is equally distributed on each of its legs. For example, if you build a table with 4 legs and place a weight of 18 on it, each leg will bear a weight of 18 by 4, which is 4.5. So, for instance, a table whose leg strengths are 4, 4, 5, 6 will not be able to bear this weight. The two legs with the strength 4 will break, whereas a table with leg strength 5, 6, 6, 8 will be able to bear it. Find the maximum possible weight that the table built out of this n leg can bear without any of the legs breaking. It can be proven that the maximum weight is always an integer. And the subsets need not be continuous. So for example, 1, 3 is a subset of 1, 4, 3, 2. So like let's see like what is the problem asking us. Problem says like you have some possible legs for a table. Let's call them W1, W2, W3 up to W1. Then you will take some of these legs, for example, W1, W2, W5, and W6, let's say. And if you create a table using these four legs, like let's say that the table is circular, so that we can print any number of legs we want. Like let's say we have used these four legs for the table. and then we have placed S as a weight on this table. Then all of these weights, all of these legs will have load of S by 4. And like this table will not break if and only if W1 is greater than equal to S by 4, W2 is greater than equal to S by 4, W5 is greater than equal to S by 4, W6 is greater than equal to S by 4. And like what we have been asked is we can take make a table using any number of legs you want. It's not necessary to have 4, we can also have 6. Then if we place weight S, then each of these will have load of S by 6. So like the capacity of all 6 of them should be greater than equal to S by 6. And what it asks us is to find the maximum weight we can place over here. And let's see how does we proceed. Let's say like we have added some weights. WI, like let's say we have placed K different legs over here. Let's call them I1, I2, I3, I4 up to IK. And total weight is S over here. Then the table will not break if W of I1 is greater than equal to S by K, W of I2 is greater than equal to S by K, and W of IK is greater than equal to S by K. And if we take minimum on this side, then we can see that the table will not break if W of I2, W of IK is greater than equal to S by K. Like if you look at the minimum weight, like the minimum weight any one of the leg can bear should be greater than equal to S by K. So if with this equation, if we want to find the maximum possible value of S over here, then max possible S is K into minimum of like it says like maximum possible S you can have is if you have K weights, then K into minimum weight each of the legs, minimum among the weights each of the legs can bear it. Intuitively, if we look at it, what we need is like if we want a table to have K different legs, then we should pick K strongest leg and see like what can be the weight it can keep up over there. And once we realize this, what we can do is we can iterate on all the possible values of K, like the number of legs the table can have starting from 1 to n. And for each of the possible case, we can see like how many weight it can bear and take maximum of it. So I have taken all the weights in input. I have sorted them in the reverse order. And like the maximum weight it can bear is I started with answer equal to 0. I will take maximum with some values and at last print 1. Now I am iterating on the number of legs the table can have. And like here I will use strongest I legs. So minimum is AI minus 1 because array is sorted in decreasing order. So A0 is greater than equal to A1 is greater than equal to A2 is greater than equal to A3 and so on. So like if you pick the I strongest weight, then the minimum among them would be AI minus 1. So I multiply it with by I and take maximum over there. And at last I print like the answer whichever the maximum case I got for the all the possible values of the legs. Like any questions on this one before I move to the next problem, which would be swap and unite? Okay, moving on to the next problem. Swap and unite. The problem statement says you have a string S consists of lowercase letters. You can perform the following operations on S. Choose two indexes I and j and swap Si with and Sa. For example, if S equal to CodeChef, choosing I equal to 3 and okay, can you explain why we take the strongest leg? Like for example, we have taken 5 legs. Let's call them W1, W3, W6, W7, W8. And if we place weight S on this, then W1 should be greater than equal to S by 5. W3 should be greater than equal to S by 5. W6 should be greater than equal to S by 5. W7 should be greater than equal to S by 5. And W8 should be greater than equal to S by 5. And if we combine all of these equalities, we will get is minimum of W1, W3, W6, W7 and W8 should be greater than equal to S by 5. And what we need is like what can be the maximum possible value of S when we can choose any 5. And if we want to increase this value of S, we should increase this value of minimum over here. And like this value, like if you choose 5 weights, and let's say like weights have been ordered in this way. Now, if you choose these 5 weights, then the minimum you will get is 8. But if you choose A1, A2, A3, A9 and A10, the minimum you will get is A10. But let's say if you have chosen A1, A2, A3, A4, A5, then the minimum you will get is A5. So if you want to increase maximum minimum value among all the bits as much as possible, then the best way to choose is to choose the strongest legs over here. Because in this case, you can see like A5 is greater than equal to A8 is greater than equal to A10. And like that was the idea over here. Like if you want to increase the minimum among all the weights, the best way is to pick the strongest weights over here. I hope my screen was visible when I was drawing circles over here. If not, then I will do it again. Like any questions before I move further? Or like just let me know if my screen was not visible when I was drawing this yellow, pink and purple circles, then I will do it again. Okay. And like that was the main idea over here. Okay, then moving to the next problem, which was swap and unite. The problem statement we read so far was like we can choose any two indexes of S and we can swap the characters at that place. and we always liked unity. To this end, find the minimum number of operations required so that at least one character that appears in S, all its occurrences forms a continuous segment in S. In short, they are united. For example, if B S is equal to B A A B A, swapping the first and third character results in A A B A B B A, and all the occurrences of B form a continuous segment. Now, see here. Note that A doesn't form a continuous segment, which is fine. And we have to find the minimum number of operations required. No, like I will not explain the random color problem because I don't know how to solve it. But fortunately, the editorial is out. You can probably check there. So, like one thing to note over here is like it says like S is the lowercase Latin letters between 8 and Z. So there are 26 possible characters. And like the string length is n over here. So like for example, if we want to make all A equal, make all characters C equal, C adjacent. Then what we can do is we can try all the starting values of the segment. Like for example, like our loop so far looks right. Up to Z, trying all characters. For start pause equal to 1 to n. These two loops so far. And like let's say if we know like the character C appears 3 times. And like the adjacent character we want is at index 6. We want to make continuous set. Then if the total character appears 6 times, then the if first character is 6, then the other character would be 6, 7, and 8. Or in general, if the frequency of the character is F and the starting character is L, then it will form continuous segment from L, L plus 1, L plus 2 up to L plus F minus 1. Basically, we have to move all the characters in this range now. And if we somehow know like how many characters know how many C are already present in this segment, then we won't have to bring those characters in this segment, and we will have to bring all the other segments. So like the number of operations required would be F minus so for example, if we take some example string, if we have this as example string CAB, and let's say this is as first character where we want continuous, because there are three C's, like this would be the range we would be looking for, and there is one C already present in this range. So we will have to bring the rest of the C's over here, one here and one here. So number of operations required would be 2. No, why we have fixed only first C? Like what we are trying is we are trying all the possible. Okay, I will try again. One thing is like if we fix a continuous range where all the characters should be, Then if we know like where the first character in that continuous range would be, we would be able to find all the indexes based on how many times a character appears. And to show this, I have taken an example string for the character C. Like I am not fixing the character C, I will try out all the characters over here. So in my example string, if character C appears 3 times, and if I fix like, and then I will try out all the positions of starting positions over here. Like this would be one possible way where the C can appear together. This would be the other case where all the C can appear together. Like this would be the third possible case where all the character C can appear together. This would be the next place where all the C can appear together. And this would be the other case where all the C can appear together. So what I'm trying is I'm trying to move this window where all the characters C would be appearing together, and I'm looking at how many C's appear in that segment. And what I know is like apart from like which the C's which already appear in this segment, I don't have to do anything for that, and I will have to move all the other C in this segment if I want to make C as the equal adjacent characters. But it's not necessary that we should have C2. Like we should also try for moving all A together, moving all B together, moving all C together, moving all D together, and up to moving all Z together. So the idea is like I try all characters A to Z. I look at the window size. Which would be the number of times this character appears. And then try all windows where they can be equal. This would be 2 for loops. And then I need some fast way to count how many is already present. And once I try out all the characters and all the possible windows, then I know like one of them would definitely be in the answer. And I can take minimum over all the tries I have done over here. And like to count the windows, what I can use is I can use prefix sum for each character. Like my implementation in code in context was slightly different. So I will implement it once again. Like I started with answer equal to size of S. Here I would be trying out all the characters. And then I count the number of characters C in this range using some prefix sum idea. Like we can add some dummy character in the starting. And I also need total count. If this character is not in string, we should ignore it. Otherwise, my total count is the window So now I'm trying out all the starting positions. Characters like ending positions would be starting position, and characters in this segment is like the number of times this character appeared in this range. Like if there is something unclear over here, like can anyone say like which part is unclear so I can try to explain that part again? Like the main idea was to try out all the possible characters which can we can bring adjacent. Okay, like the main idea is like there are only 26 lowercase Latin letters in the string C. Why I'm not able to find it? Like if I look at the problem again, it says to find the minimum number of operations required for at least one character that appears in S. All its occurrence forms a continuous segment. So what I am trying to do a brute force on is all the possible characters that appear in S, and then all the possible continuous segment for that character. Like for at least one, all the characters that appear in S, because I know that they are lowercase letter. So I'm trying out all the possible values of that lowercase letter. And if I know like a character appears 5 times, let's assume that if a particular character appears 5 times, like brute force is on, because we want at least one character to be in continuous. What we can try is like we can try like how many operations required to make that character equal over there. And like let's say a character has appeared 5 times. Then like question next question is like what can be the possible segments where they can appear together? So like they can be together either in from 0 to 4, or they can be together from index 1 to 5, or they can be together from index 2 to 6, or they can be together in index 3 to 7. They can be together from index 4 to 8, and so on, and at last would be n minus 4 to n. Like these are the possible segments where a character which appears 5 times in the original string can appear over there. And like once, and if like for example, if I want to see like how many, if I if the question is given a character C, let's not call it C, let's call ch. Given a character which is variable name ch, and the range L to R, how many swaps are required to move all characters ch in range L to R? If we can answer this question, then what we can do is we can brute force on all the possible characters ch, and we can also brute force on all the possible ranges L to R. And the idea for L to R is the length of L to R is equal to number of times character ch is in the given string. So if we fix L, then based on the length we will also know like what would be the other range. Then we can try out like, then we can, if we can answer this question for like let's all the characters which are in the given string, and if we try out on all the ranges, then we would be able to find, yeah. And like that's what I am trying. Like the question asks us to find minimum operations required so that at least one character appears in S and all its occurrences form a continuous segment. So there are two parts to it, like at least one character in S and all the continuous segments. So if we brute force on all the characters that appear in S and all the continuous ranges for that character, and if we take minimum among all of these possible values, like that would be the minimum for our answer as well. And the way to find it was I brute force on all the characters that appear in S, and then the idea was to use prefix sum to count like how many times a character is already present in a given range. So like if the total number of times this character is present is 0, then I ignore it. Otherwise, if I fix the starting position, then I also know like the end position of the range to bring all the characters over here, which would be starting position plus total count minus 1. And the next question is like how many times the character this character C appears in this range, and that was done using prefix sum idea. And at last I am taking the answer as minimum as like total number of times this character C appears minus total number of times this character C is already present in this given range. Like all the other occurrences which are not in this range should be moved to give the given range. Like any part which is still unclear, I can try to take that. And if not, then I will move to the next problem for today. Okay, make it one says you are given two positive integers L and R, where L is less than R. Let N is equal to R minus L plus 1, which is the number of integers in range L to R. Consider the array L plus 1, L plus 2 up to R of length n that contains every integer from L to R exactly once in order. And we have to find an integer B of length n such that every integer L to R appears exactly once in B. Like note that this is possible because the length is equal to the total number of integers from L to R. And for each I from 1 to n, AI GCD of AI and BI is 1. And if no such B exists, print minus 1. And now if we look at the example, it says if we look at all the integers from 3 to 7, then the one possible way is 7, 3, 6, 5, 4. And here in the example, it takes GCD like A1, A2, A3 is 3, 4, 5, 6, 7. And the GCD for each pair is 1. And the sample does not contains any case where the GCD is minus 1. So like let's try to find like the minimum case where the GCD can be minus 1. Like my idea for this problem was so like let's first analyze the case where an answer is minus 1. Let's say like original array has O odd numbers and E even numbers. O and E are variables. Then if total number of even numbers is greater than odd number, then however you place, like there would be a place where two even numbers would be at same place. For example, if you have O1, O2, O3, E1, E2, E3, E4, then because you have to place four even numbers, like for these odd numbers you can only place three even numbers, and E2 would be somewhere here. And when two and now like wherever this character is, like their GCD would be 2 at least. Like if in the given range, like the number of even integers is greater than number of odd integers, then we will not be able to pair up with odd and even integers over here. Like if for some, if we pair up GCD of two even number and even number is a multiple of 2, and if total number of even integers is less than equal to total number of odd integers, then my claim is like there will exist a way some B over there where the answer can be there. So like this was the first part of this problem, and like that condition was handled here. If the total number of events are odd, and if the starting, like this is certainly the simplified condition, when like number of odd integers, number of even integers are greater than odd integers. And if you want some name for like how do you prove it, like then there is principle of mathematical like it's commonly known as pigeonhole principle. Like this is a mathematical name for it. And the intuitive way to look at it is, like let's say if you have 5 even integers and 3 odd integers, and if you rearrange these 8 integers somewhere, then with those 3 odd integers you can only pair 3 even integers. So like remaining 2 even integers must be paired with some other even integers. So in that case, like the GCD of those two numbers would be 2 at least. Like because GCD of 2 even integers is a multiple of is even number itself. And similarly, if you have 5 odd integers and 3 even integers, then you can pair up 3 even integers with 3 odd integers, and other odd can be there. They may have GCD 1 or not, but that's not the case. And now the next case was like if you pick, the other thing was to realize was the GCD of any two continuous number is 1. And this also comes up from the fact that any two adjacent integers are pairwise coprime. Like for example, if you run your regular GCD algorithm, like if you try to find GCD of two continuous numbers, then after the first step it becomes GCD of I comma I plus 1 mod I. And like if you see, like this remainder is 1 again, assuming that I is not equal to 1 for now. And now in the next step, like if you take GCD of I mod 1 comma 1, this becomes like this is 0 then. And now your recursion will terminate and you will return like this as your GCD. And similarly, you can see like here I have said I not equal to 1. If you try out separately, GCD of 1 comma 2 is also 1. So like the idea was, let's say if you want to find the answer for range 5, 6, 7, 8, 9, 10, 11, 12. We can pair these two integers together, these two integers together, these two integers together, these two integers together. And if we call this as an array B, then this will work. But the problem happens when the total number of like there can be a case when the last 3 digits cannot be paired together. Like if total number of digits are odd, then now if you pair 13, 14, 15 will left hanging outside. And you cannot write 15 here because in this case the GCD would be 15. So what we can do is we can try out all the pairs, and if total number of integers are odd, then we should try to figure out like these 3 pairs over here. And the way to go here can be 14, 15, and 13. You can notice this will work because these two are adjacent, and GCD here is not equal to 1 over here. And like in general, it can happen that like this last pair cannot have, like this last pair in this algorithm, like this last pair is a problem here. Like if we pair L plus 1, L plus 2, L plus 3, L plus 4, L plus 5, and so on, n is odd, then our last pairing becomes R minus 2 paired with R minus 1, R minus 1 paired with R, and R paired with R minus 2. And in this algorithm, like all the characters are adjacent, like difference is only one apart from this pair. So if GCD of is 1, then this pairing is valid. And my claim is otherwise print minus 1. If total number of characters are odd, and if the last pair is matched up. And like basically this happens, like this case happens only when like number of odd integers, even integers are more than number of odd integers. And this is essentially the same conditions which I was discussing earlier. Like here I was taking care of the case when total number of characters are odd, and like the starting character would be one extra time over here. In that case I was printing minus 1. Otherwise if total characters are odd, then I'm writing the first three characters, you can do last three as well, which would be L plus 1, L plus 2, and L. This would be paired, L plus 1 would be paired with L plus 2 would be paired with L plus 1, and L would be paired with L plus 2. And for all the other characters, like we can start with J equal to, after these three characters, L plus 3 up to R, jumping in the swaps of 2. Here I am pairing J with J plus 1 and J plus 1 with J. And if total number of characters are even, total number of integers, sorry, then I can directly start doing in the pairs of 2. Like, and like it, you can probably take it as a homework. Like or like the best way to do it, like let's not do anything here. Like any part which is not clear in this problem, I can take that again. And the main problem comes up from the fact that any two pair continuous integers have GCD1. And if you knew it, like the problem would have been easier, and otherwise it would have taken you some time to get a hang on what's required. And moving to the next part now, it says you are given two integers and an x. Count the number of distinct arrays of length at most n whose LCM is equal to x. That is, find the number of arrays A such that the length of A is between 1 to n and LCM of A1, A2 up to all the integers is x. Two arrays are considered different if their length are different, or they have same length but there is some index where the value is different and we have to output it modulo somehow. Like, let's first focus on this part first. Like, how do we find the LCM of all the integers? Like, if we look at the prime factorization of all the integers, and let's say a1 is equal to p1 to the power k1, p to the power k2, p to the power k3, p4 to the power k4, p5 to the power k5. A2 is equal to p1 to the power l1, p to the power l2, p3 to the power l3, p4 to the power l4, p5 to the power l5, and a3 is p1 to the power m1, p to the power m2, p3 to the power m3, p4 to the power m4, p5 to the power m5. Then LCM of a1, a2, and a3 is, like, we have to take max power for all of these primes over here. Max of k1, l1, m1 into p2, max of k1, k2, l2, m2 into p3, which is max of k3, l3, and m3 into p4, which is max of k4, l4, and m4 into p5, which is max of k5, l5, and m5. Basically, to summarize this part again, like, if we look at all the primes which are present in all the integers which divide all the integers of the array, and if we try to find the max power in all of these, then LCM should have at least that power of prime. For example, let's say we want to take LCM of 6, 9, and 16. These are the three numbers. Then 6 is 2 to the power 1 and 3 to the power 1. 9 is 2 to the power 0 into 3 to the power 2. 16 is 2 to the power 4 into 3 to the power 0. So LCM is 2 into max of all of this into 3, like the max for this, which would be 16 into 9, 144. And you can verify that 144 is LCM of 6, 9, and 16. Like, any questions on this part first before I move to the further problem? Like, once I look at GCD like this, what I need is prime factorization of x. And let's say x is equal to p1, a1, P2, A2, P3, A3. Let's not call it A, that will cause confusion. Let's call them C1, C2. Then all the numbers A1, A2 up to AN should have prime factors P1, P2, and P3 only with some powers. And some powers over here. And the max of these powers should be A1, A2, C1, C2. And like for example, in this case, if we have fixed 2 to the power 4 and 3 to the power 4, like each of the number can be multiple of 2 to the power 0, 2 to the power 1, 2 to the power 3, 2 to the power 3, and 2 to the power 4. And there should be at least one number which is a multiple of 2 to the power 4, so that the max comes out to be 4. And similarly for C, it would be 3 to the power 0 into 3 to the power 1 and 3 to the power 2. And there should be at least one number which is a multiple of 3 to the power 2. And now we can independently solve it for each prime, and then we can try to find like how many integers are there. And we can iterate on the length of n as well. Like I took t as number of input and m as input, and then my max power array contains like maximum power for each prime factor. This is prime factorization algorithm. Like for I start with for all and if p does not divide m, it continue it. Otherwise, keep dividing p by m and count how many times it appears and add this into a prime factorization. And after this, m is 1. If m is greater than 1, then that would be the last prime factor, the largest prime factor over here, and its power is 1. Like this is prime factorization loop. You can probably read it on some online as well. And then I'm counting answer by iterating on all the possible values of length from 1 to n. And then I'm counting how many permutations, how many arrays are there. That would be for each prime power. There would be power plus 1 to the power length. Like this would be the this counts the number of arrays which contains all the prime powers from 0 to power plus 1. And because I want at least 1 to contain like the exact power p, so I subtract the cases when all the powers are between 0 to power minus 1 and multiply it for all the prime factors and add that to the answer. And when we are running it on all the lengths, this would be our total length. Like any questions on this one before I move to last problem for today? Okay, last problem says you are given a tree with n vertices rooted at vertex 1. Each of these vertex will have either 0 people or 1 people standing on it. Consider the following process on tree. Let score you denotes the score of vertices. Initially, this is 0 for all the vertices. Each second, each person in tree will simultaneously move one step towards the root. The only exception is people already starting at the root. They will instead leave the tree entirely. For each vertex u, if exactly one person entered u in this second, increase score by 1. Otherwise, don't change score u. Note that this means nobody entered vertex u, or at least two people entered simultaneously. This process will repeat till nobody is standing on tree anymore. Initially, there are no people standing on the tree. Process Q queries update of the following form. Given you consider the above process performed with the current set of people standing on the tree and find the value of score u after it ends. Given you toggle the state of person standing at vertex u. This means if nobody is standing at you, then place one person there. Otherwise, remove the person standing there. Note a tree with vertex u is connected through directed graph with n-1 edges, and everything is given here. Like, let's first draw a random tree over here. Like, the first thing to note here was only people which are at same height can be together always, because everyone moves one distance up over here. If we look at this node, then this is the path. And if we look at this node, like this would be the path, but this would the yellow path would be one step forward always. Like initially green is here and orange is here. After one step, this moves one step up and this moves one step up. Now green is here, orange is here. And after this step, green moves here and orange moves up. And like this will always repeat. So like what we essentially need is like when we have to score you, like the number of times when only one vertex entered you. And that would be if this is the subtree of you. Like then only these vertices can enter you because everyone else will follow a different path. And if we look at heights of all the nodes in the subtree of you, then only heights which appear only once can increase score, can enter single-handedly. Like if a height appears two times, then when that after that when those two nodes will reach together on that height. Like over here, like these two nodes will start traveling together from this node. So when they reach you, like they would be together. Or if these two are at the same height, Then after point 1 they would be here, and after point 2 they would enter U together. While if this is the only node, then when it enters U, it would be the only node to enter here. And once we realize this, we can also maintain like now we have to solve independently for each node. Like let's say this is the tree, and let's say this is the height where I'm targeting at, looking at, and these are the nodes where someone is standing at. And what I can see is like this node will contribute one here, but when it reaches here, other nodes will come up. This node will contribute one here and one here. No, one will not contribute here because like this node contributes one here, and here two nodes comes in, and this node will contribute one here, and here multiple nodes comes in. So the places where these four green nodes have contributed is the idea is if we order these nodes like Euler tool is a prereq for this problem. Like if we look at all the nodes and we order them at same height and order them by their t in time, then we have to only look at the adjacent nodes in this sorted array because they would be the first one to collide. Like same observation is also used in virtual tree or auxiliary tree. Like if you read like this would be really helpful for this one. So like now insertion and queries, like if you like look at a particular nodes at a particular height, and let's say if you inserted a node over here in this order, then like this node and like this new node can impact a node just before it, a node just after it in this order. So you should recompute answers for like these three pairs over here. Earlier 2 was either colliding with 1 or 4, and 4 was either colliding with 2 or 5. Now when you insert a 3 in between, then 2 can either collide with 1 or 3. 3 can either collide with 2 and 4, and 4 can either collide with 3 and 5. So the idea would be whenever you are reinserting, you should recompute the answers for 3 different nodes. Earlier, like 2 of the existing nodes can be impacted, and you have to definitely compute the answer for 3. And like look at like for each node, you should look at how many ancestors can be single over there. Like there would be some ancestors here, and that's it. This is how the tree look like. And like this is how the path will be. And at last everyone will be together. So like based on this, like you should add +1 to these paths over here. And like this +1 can be done using, like you can use a lot of method to add +1 to a path and subtract -1 from a path. And now let's say you have removed 3 from here. Then you first remove this +1, and then when you have removed 3 from here, like then 2 has been impacted where the neighbors are 1 and 4. Now that +1 should be on this path and this path. Like 4 and 5 are unimpacted over here. Like 1 and 5, this remains same. And now let's say if some other node 6 is present in this path over here, then like 6, when it's moving up to this path, it would be alone. After that, it would be joined by some other nodes here. And like this was the main idea. Like here I am taking graph node as input. I am maintaining height for each node and parents of all the nodes. And I am also taking T in T out on the Euler tool. Then I am running a DFS algorithm to compute the parent for each node, starting time, ending time in the Euler tool, and height for each node. Then I also found the maximum height. And now one Boolean variable whether a person is present at a node or not. This would be used to toggle the state. And this set and max height would be the sorted order based on t in time for each height. And then I also have an LCA tree to find the LCA for a node height. Then queries. If queries of type 2, I should update the status of person 2. Otherwise, I should find the number of heights which are present only once in this subtree. Height greater than 2 denotes at least 2 nodes would be together when that node reaches this height. Height 0 denotes no one is present at that time. And updating person looks at it like I first find all the neighbors, like where you would be inserted or removed, and 2 people before it and 2 people after it. Like get neighbors, like I look at all the nodes which are at this site and a particular time this node was added. Then using the lower bound function is that function to find 2 people before that in the sorted order and 2 people after that in the sorted order. And if that person was already present, then I should remove the +1 on all the paths where I have done for the all the 3 nodes. The impacted node would be this is the current node, this is the node just before it, and this is the node just after it. and then I have to re-update it with the answer for one before it, one after it. Otherwise, I should insert that key in the order. Here I am erasing it. I should remove plus one all the at all the ancestors which were done by one person before it and one person after it, and then re-update the answers for all the three nodes over here. Here update node ancestors takes one person before it, one person after it, and like whether plus one should be done or minus one should be done, and the current node. Minus one denotes like no such ancestor or person exists. So for minus one case, just remove it. Otherwise, find the nearest ancestor for both of the nodes. Like for example, if we have three nodes, either this can be the case, in which case for u2 only up to this is the nearest ancestor. So only these nodes should be plus one happen. Or like they can look like this. In that case, this would be the nearest ancestor. So wait 1 second. Sorry. Let me just draw it again. Either this is the middle node, this is the node just before it, and this is the node just after it. Either this u1 collides with together first and then moves up. In this case, I should add plus one on this path. Or u1, or like the path would be like this. In that case, I should add plus one on this path. Because from here onwards, u2 and u3 will move together. And if a graph is like this, then from here on, u1 and u2 will move together. So I look at which is the nearest ancestor based for both from u1 and u2 with the max height. And then here I am adding plus one, like here I am using Euler 2 idea to add subtree sum over there. And like this was essentially the main idea for this problem. Like I would recommend like reading out Euler 2, like this is like it comes up a lot of times and really helpful over there. Like are there any questions which anyone wants to ask that I can take up before I call it a day today? Like if there are no questions, then I will call it a day, and thanks everyone for joining.